Hello, kids. Today we are starting a new chapter. It's chapter 7, lesson 1. And the main essential question that we're talking about in this chapter is going to be how are patterns used to solve problems? Okay, so and we're talking about a lot of patterns in this chapter. So here we go. A numerical or numeric expression such as 8 plus 7 is a combination of numbers and at least one operation. Okay, I mean you could say 8 times 7, and that's still a numerical expression because there's at least two numbers or combination of numbers, and there's at least one operation there. And you can find the value or evaluate the numerical expression by completing each operation. So what we're going to end up building up to is where we're doing these orders of operation, where it's like, 8 times 7 plus 3 minus 2, and then we're going to decide which order that we're going to do those in, because this one we can do as written, but sometimes when you have one like 8 minus 7 times 3 divided by 2, we have to do these in a certain order. So that's what we're going to build up to get to where we need to go. So draw it is the first one. This obviously this is a hands-on. So this is draw it. Gregory and his family went hiking over the weekend. On Saturday, they hiked 5 miles, and on Sunday, they hiked 5 miles. So, this could be Saturday, this could be Sunday right here. They hiked 5 miles on each day. Use the bar diagram to write and evaluate two numerical expressions to represent the total numbers hiked. So again, what they did was they drew like a little bar graph here, and okay, that works. It kind of lets you know, like, okay, they did 5 here, they did 5 here, and then they said, well, what is the total number in between here? You can look at that, and hopefully you'll see that, well, 5 plus 5 is 10, Mr. Young. That's easy. And we are starting out fairly easy in this first part. But again, you have 5 plus 5, which is the addition expression that we're making here. And then we evaluate. And again, evaluate, as you see up here, it's finding the value, which just means just do the problem. Okay, evaluate just means do the problem. So 5 plus 5 equals, obviously, 10. That seems extremely easy, but trust me, this does get a little bit harder. Now it says use the bar diagram to write a multiplication expression. So we're going to look up here and say, well, I see two fives. Hey, multiplication, 2 times 5. So then you evaluate it. 2 times 5 equals 10. So they hiked a total of 10 miles. All right, this seems easy, I know, guys. But trust me, this will build into something that is a little bit harder for you, and this will help you. All right, so Mrs. Yearling has two groups of 5 students and two groups of 4 students. Use the bar diagram to write and evaluate two numerical expressions to represent the total number of students. All right. So as they did, they used a bar diagram, and I think your assignment's going to have you do that as well. But she has two groups of 5. So here's the two groups of 5 right there. Okay, they drew out two groups of 5. And then it says she has two groups of 4. So we do that as well. We have two groups of 4. All right. Now it says use this up here to write an expression using only addition. So we can see, well, 5 plus 5, and then we're going to add 4 plus 4 together. And then it says evaluate the expression. All right, well, 5 plus 5 plus 4 plus 4, well, we say 5 plus 5 is 10, and then 4 plus 4 is 8, and we add those together, we get 18. Now it says use the bar diagram to write an expression using multiplication and addition. Okay, now this gets a little bit more difficult. You look up here and you see, well, there's two 5s, right? So there's two groups of 5, and there's also two groups of 4. And as you can see, the addition part is right there where you add those two together. Because you're not going to multiply those together, you're going to add those together. So we're going to evaluate the expression. Okay, well, I know that this is 10, and I know that this is 8, and I add those together, I get 18. So there are 18 students that are divided into groups. And the helpful hint here says parentheses tell you which numbers to group together. Perform operations inside the parentheses first. So everything that's within the parentheses, you're going to do first. And we're going to talk about later on in the chapter a thing called Pemdas. Okay, you do parentheses, you do exponents, then you multiply, you divide, you add, and subtract, and that's the order that you're going to do these in. So this is what the important thing is, that you do parentheses first. Write that on your page right there, because again, we're going to refer back to it in later lessons. Evaluate the addition expressions to find the sum. Does the order in which the expression is written change the sum? So these are the same numbers, right? 7 plus 7 plus 5 plus 5, 7 plus 5 plus 7 plus 5. So that you have two 7s, you have two 5s. Okay, so we need to evaluate it. First of all, let's talk about, does changing the order of these numbers make a difference? Well, hopefully you thought in your head, no, because remember we had that property of commutative property of multiplication and addition, where it doesn't matter which order that these numbers are written in, you're still going to get the same sum. So, if we add this one together, we're going to get 14 and 10, we're going to get 24. This one we're going to get 12 and 12, which is 24. So does the order in which the expression is written change the sum? We're going to say no. The order in which the expression is written does not change the total, which is 24. So again, you got to remember that the commutative property of addition and multiplication, it doesn't matter which order you take. Now remember, this was associative where we did that. We put in different groups, all right? But this one is just changing the order of the numbers up. Okay, suppose Mrs. Yearling also had another group of 4 students. Write 2 numerical expressions to represent the total number of students. So they're saying, well, what if she had another group of 4? So she had the 2 groups of 5, which are that right there. And then she had another group of 4, which is right there. Now, 2 times what? Well, there's still 2 5s here, right? So we're going to write 2 times 5. Well, how many 3s are there now? There's 3 of them, right? So it's going to be 3 times 4. All right? And it technically doesn't ask us to find the answer, but I'm going to anyway. This is 10. This is 12. We have 22 total students. Okay? All right, let's turn the page to the practice it side. Okay, practice it. Now, Caleb's music class is divided into 5 groups of 4 students for a project. So we're going to use the bar diagram to write and evaluate 2 numerical expressions to represent the total number of students in his music class. So it says he has 5 groups of 4. So here's a group of 4, a group of 4. So that's 5 groups of 4. That's how they did that. So we're going to write an addition one first. The addition one should be easy because you just look at it and say, well, 4 plus 4 plus 4 plus 4 plus 4, right? That's easy. And then it says write one using multiplication. Okay, well, let's go ahead and add this up. 4 plus 4 is 8. 8 plus 4 is 12. 12 plus 4 is 16. 16 plus 4 equals 20. Now we're going to use a multiplication. Make a multiplication problem. We're going to write and evaluate. It means we're going to write the problem like we did here, and then we're going to evaluate it, find the answer there. Okay? This one's even easier because we just count. Well, how many 4s are up here? 5. 5 times 4, which equals, hopefully you'd see 20. So there are 20 students in his class. That one's pretty easy, wasn't it? Let's look down here. Identify structure. Bailey's soccer team had snacks after the game that included 12 granola bars, 12 mini muffins, and 14 bananas. Use the bar diagram to write and evaluate 2 numerical expressions to represent the total number of snacks after the soccer game. So again, she had 12 granola bars, 12 mini. We're just adding all those. Look, we have 12 granola bars, 12 mini. We just stack them like that. And then this line right here means the total amount of them. So we're going to write an addition problem right here. Okay, so we just take 12 plus 12 plus 14, and then we come up with the answer. We say, well, this is 24 plus 14, which is 38. Now we have to write a multiplication problem. Write and evaluate. We have to write a problem and find the answer. So we look up here, we say, well, there's two 12. So we're going to say 2 times 12. That's a group right there. We're going to do that first, and then we're going to add 14, which again, this equals 24, which equals 38. So there's a total of 38 snacks after the game. All right. Seems pretty easy. It's just the key thing here is having you guys do a multiplication and addition problem on the same problem. Can you see me now? All right. Wassa went bird watching and spotted 6 robins, 5 arrows, 6 cardinals, and 6 doves. Use the bar diagram to write and evaluate 2 numerical expressions to represent the total number of birds Wassa spotted. Okay. Well, 6 robins, got it there. 5 sparrows, got it there. 6 cardinals there, and 6 doves. And altogether, you would add it. So you're going to write and evaluate an expression using only addition. So we say 6 plus 5 plus 6 plus 6. And we're going to add those up. This is 11, 17, 23. 23. But now it says we're going to write and evaluate using multiplication and addition. All right. So we're going to go up here and say, well, 6s. Looks like we have 1, 2, we have 3 6s. So we're going to say group 3 times 6 group. That takes care of this, this, and this. And then we're going to add that last one on plus 5. And again, we would look at this and say, well, this is 18. 18 plus 5 is 23. So there's a total of 23 birds that Wassa spotted. Got it? Okay. Down here, which one doesn't belong? The bar diagram below can be represented by 3 or 4 expressions underneath. Find the value of each expression and circle the one that does not represent the bar diagram. Okay? So we're going to find the total here. So we're going to say, well, this is 9. 9 plus 5 is 14. 14 plus 4 is 18. 18 plus 5 is 23. 23 plus 4 is 27. Okay. This one is 15, and this one's 12. You add that, we get 27 on that one. So it looks like those two are the same. This one here, you get 3 plus 5 is 8. 8 plus 3 is 11. 11 plus 4 is 15. Oh, that's the one right there, because those two are alike. So if we do this last one, and we have 3 times, this is 9. Well, that's 27. So it looks like 15 is that one there is the one that doesn't belong. Okay. It says now that the bottom here, how can bar diagrams be used to model numerical expressions? Well, that's easy. The number of times each number in the expression is used can be shown in the bar diagram. So the number of times each number in the expression is used can be shown. So again, each time the number is used, like up here, put it in the bar diagram. Each time these numbers are used in this, put it in the bar diagram. Okay? Because this was the bar diagram right here that they made these expressions with. So again, it's just the number of times each number in the expression is used can be shown in this bar diagram. Okay? So, homework. it gives you another example right here. You know, I'm going to be giving these all back to you every day, like I've been doing. And I would highly recommend keeping these in a folder. Keeping them in your folder and throughout the entire chapter so that you can go back and reference things as you go along if you forgot how to do something. Because I noticed that last chapter, by the time we got to the very end, you had forgotten how to do the very beginning, and it'd been easy for you to go back and kind of check out what you were doing, and it's like, okay, yeah, now I remember that because you got your sheet right there. Okay, so keep on to these, and then at the end of the chapter, throw them away. Okay, just you might have it for a total of 2 weeks in your folder. It's no big deal. So they give you another example right here. Now the homework, refer to the homework helper, which you got to go back up here to look at. All right. And then it asks a new question. So basically, you're adding, I think, something onto this problem here, like we did on one of the other ones in the they apply it. The backside, again, you need to make sure that you're writing and evaluating. You write and you evaluate. It means you write the problem and you answer it. This one's only addition, and then this one is multiplication and addition. It's both. Okay, and put your answer right here. Same thing down here. Okay, I know this isn't going to take you all that long. I know that already. This is a very easy assignment, and as I said before, there wasn't a whole lot to it. So when you're finished with this, make sure you turn it in. Make sure I didn't do this in the very beginning, but make sure you have it stapled. These are pages 481 to 86, I believe. Is that what we have here? Yeah, 86 down there at the bottom. All right. And good luck, guys. If you have any questions, again, if you have something written down, I'll help you. If not, write something down, try it out, and then come ask me, okay? Or just rewatch this video. Thanks, guys.